Okay, let's kick off trigonometry with some vocabulary about angles. So let's look at angle ABC over here. So we could write that as angle ABC. It's got rays BA and ray BC, and they meet at the vertex at B. So we could also call this simply angle B. Conventionally, when we talk about angle B, we'll probably think of theta 1, what's labeled here as theta 1, as the acute angle. And because we're moving from BC to BA in a counterclockwise fashion, theta 1 we're going to say is a positive angle. We're going to agree that if we're moving counterclockwise, looking at it counterclockwise, that we're going to give this a positive value in degrees or even in radians, another measure for angles. If we're moving from the initial side, BC, so there's some new words for you. This is the initial side of the angle, to the terminal side, BA. This is the terminal side of the angle. If we're moving in a counterclockwise fashion, as we are for what's labeled here as theta 2, we're going to give that angle a negative value. Because theta 1 and theta 2 go from the initial side to the terminal side, from the same initial side to the same terminal side, so to the exact same location, but just move in different directions, we call those coterminal angles. Okay, so let's play with coterminal angles. So let's look at the XY plane. Here it makes it much more clear where the initial and terminal sides are going to be. We talk about angles being in standard position. So all of our angles will be in standard position, which means that the initial side, let's try that again. The initial side is on the positive x-axis. So we don't need to draw that in. If we have an angle in standard position, we know that the initial side is on the positive x-axis. So if we had an angle here, for example, and we want to give it a positive value, let's just call that theta 1. This would be our terminal side here. And of course, this angle, since it's indicated to be counterclockwise, is positive. That's not exactly what we're going to talk about because our question looks a little bit different. We're asked to draw coterminal angles or indicate coterminal angles for 120 degrees. So 120 degrees is somewhere between 90 and 180 degrees. So let's say about here, that's not quite big enough for 120, but there we go. So I'll label that as positive 120 degrees, and we're asked for coterminal angles. So coterminal angles are any set of directions that will take you from that same initial side to the same terminal side. So what that means is we could go 360 degrees and then another 120 degrees. It's the long way around, but the angle is coterminal to 120 degrees. So we take 120 degrees and we add 360 degrees to it. That gives us an angle of 480 degrees. That's this one. And 480 degree angle is coterminal to 120 degrees. We could also go the other way. So imagine going up to the terminal side and then backing up by a full 360 degrees. So you're taking 120 degrees and you're backing up 360 degrees. In other words, you're starting on the positive x-axis, the initial side, and going to the terminal side in a clockwise fashion. So we should expect a negative value. And in fact, we do see here negative 240. You can just think of this as what's the difference between 360 degrees, the whole circle, and 120? Well, it's 240 degrees, but since I've drawn this going in the clockwise direction, I'm going to give that a negative value. And you can carry on like that. You can go negative 360 degrees and then another negative 240. That will give me negative 600 degrees. That's another coterminal angle. So because these are coterminal angles, we can expect that they'll have very similar properties. They'll have the same trigonometric functions regardless of how they're expressed, because the angle, the initial side, the terminal side, that's the same in each case. All right, to finish off our vocabulary discussion, we usually organize our XY plane, our coordinate plane, into quadrants, and where we're on the positive x-axis and positive y-axis. So your x and your y coordinate are both positive. If you have an angle running through that, you've got an angle that is in quadrant 1. So we're talking about an angle, maybe theta 1 here, that's somewhere between 0 degrees and 90 degrees. And anywhere I stop along that terminal side, your x and your y coordinate will both have positive values. If you have an angle between 90 degrees and 120 degrees, so something over here, let me run that terminal side. I'll call that theta 2. Theta 2 is in quadrant 2. If I think of it in terms of x, y coordinates, the x's are negative and the y's are positive. An angle in quadrant 3 is greater than 180 degrees, but less than 270 degrees. So here we have 90 degrees, 180 degrees, 270 degrees, adding 90 each time. And of course, the x values will be negative, as will the y values for any point along this very randomly drawn quadrant 3 angle. If an angle is anywhere between 270 degrees and 0 and 360 degrees, 0 degrees is of course coterminal with 360 degrees, then that angle is in quadrant 4. Again, I'm drawing that the direction here as counterclockwise. We're talking about the positive name for that angle. Of course, if we're in quadrant 4, your x components must be positive and your y components must be negative. So we'll spend a lot of time talking about what happens to the trig functions in each of these quadrants. We will start talking trigonometry in terms of right angle triangles, but we can always move trigonometry to the coordinate plane and talk about it in these 4 quadrants as well.